Alright, so the last few lessons we've been working on finding volume of our three-dimensional shapes. And in this case, we have a compound figure. So we're going to still use our volume formulas in order to solve this. And we have been learning too, we know that volume is equal to our length times our width times our height, or volume is equal to the area of the base times the height. Now in this case, you can notice that most of these examples we're going to see today, they did not give me the area of the base. So we're going to be focusing on this formula right here, which I know a lot of you like. If you want, you can pause this video and click on the live link and join me at 2 o'clock today, and I will walk you through these lessons and these practice problems. But otherwise, you are free to watch the video and do the problems this morning or any time when you would like to. So here we go. So this is a compound figure. Really all it is two rectangular prisms that they have pushed together to make one larger shape. So what we want to do is break down that shape. And you have a couple different options when you're doing this. You can choose, I like to use another piece of paper sometimes, to split the shape like this. So if you guys imagine, it's as if I cut off this part of the shape over here, and then I'm left with just this rectangular prism right here, and then it would leave me with this rectangular prism, sorry it's kind of hard to show you, over here that I would need to find the area of. So I'm going to choose to do it that way for this one. So I'm going to go ahead and I'm going to draw that line right here. And now I've divided this into shape number 1 and into shape number 2. And I always like to label mine so I can follow my work as I'm going. So in shape number 1, to find the volume, it's equal to our length times our width times our height. So now I just need to make sure that I have those 3 dimensions. So as I'm looking right here, I can see that the length right here is going to be equal to 9. So I'm just going to label that's length. Width in this case is actually how wide it is. It's going to be this shape right here because it's this right here. So both of these, if this is 8 here, then that means this over here is going to be 8, which means that bottom part is also going to be 8. So I'm just going to go ahead and label the 8 as my width. And then for my height, this one's nicely labeled right here. So this is my height. This is 2. So if this is 2, this is also 2, this is also 2, and this is also 2. So now that I have my length, my width, and my height, I'm going to plug in my numbers. And I get, this is a 9 by 8 by 2. So 9 multiplied by 8 gives me 72. 72 times 2. If I know 70 times 2 is 140, I could then break it down to 2 times 2 is 4. So then I can do that in my head is 144 feet cubed. So that's the volume of shape number 1. Now I'm going to move on to shape number 2. And in shape number 2, I'm going to have to do a little bit of subtraction to figure out which one's which. So in this case, I know that the length of the entire shape, if I had gone this way, was 14. But I really only want this part right here. So if I know that this whole thing is 14, and I know that this part right here is 9, that leaves this part right here has to be 5 feet. Because 14 minus 9 equals 5. So we have 5 by 3, so there's my length, there's my width. And then my height, again, as I said before, if this is too high, all of these heights throughout my shape are going to stay at 2 feet. So that's my height. So volume equals our length multiplied by our width multiplied by our height. Plug in 5 for your length multiplied by 3 for your width, and your height is 2. So volume equals 15 times 2, because I'm just going to go ahead and multiply those two together really quickly. And then I get volume is equal to 30 feet cubed. So my last step is to find the total volume of shape. In order to find the total volume, I'm just going to take my 144, and I'm going to add 30 more to it, and then I get 174 feet cubed. So that right there was one way that you could have solved the problem. I just want to show you that I did actually do this problem another way the first time I did it. The first time I did the problem, if I just slide this over here so you guys can see, I actually decided to cut it this way, and that gave me this shape right here and this shape right here. But again, even when I plugged in my length 9 by 5 by 2, and then on this shape, my larger shape, I had a 14 by 3 feet by 2 feet, and I went ahead and plugged in all of those numbers right there for shape number 1 and shape number 2, and I think I actually have them labeled backwards. So, sorry, I erased it and added it in after. So, just so it's clear for you guys, shape number 2 was that longer one right here. So I did the 14 multiplied by my 3 multiplied by my 2, and I got 84. And then in this one, I did the 9 by 5 by my height of 2, and I got 90. And even though it was a slightly different approach, I went ahead and added those together, and that was another way where I ended up with my volume being 174 feet cubed. So that's how we can approach that first example right there. I do want to do one more example with you. Those numbers right there weren't too large yet. Probably something I could do without a calculator. Don't need that yet. As we start getting to higher numbers, if you feel a need to try to do them with a calculator, I am okay with that. Especially later on, you're going to start seeing decimals with these. So I'm not going to throw this at you this year, don't worry. But I definitely would encourage a calculator as the numbers get bigger. But otherwise, it's just great practice for you to do it without a calculator. So in this case, here's a second example right here. What I would probably do right here is, I'm deciding which way I could cut this and how I'm going to do my shapes. So again, just kind of letting you see that I could decompose it into 2 rectangular prisms. One option I would have would be to go this way and slice it so that I have this long rectangular prism here. And then that would leave me with that tall rectangular prism right here to find. It's really up to you which way you want to cut it, whether you want to go here or whether you want to go here. So for my first example, I'm going to go ahead and I'm going to slice it. I'm going to go across. I'm going to make that long one like this. And so this right here is going to be my shape number 1, and then we'll call this one here my shape number 2. So if I want to find the volume of this first rectangular prism, I'm going to kind of ignore that part on top. I can see right here I have 19 for my length, 5 for my width, and I just need to figure out that height. So there's the height there. It would be the same as this, but it's not labeled, which would be the same as this part from here to here. Well, unfortunately, they didn't label this entire, they didn't label this entire thing. We know the whole thing is 17, but I really just want to know this part right here. So I have to look around on my shape for that other dimension that's going to help me. So if this right here is 17, and I know that this part right here is 10, that's how tall that extra part is. So I'm just going to, in my mind, imagine that I take that part off. So that means this part's 10 from here to here. And if I know that this is 10 and this whole thing is 17, that means this has to be 7. So I'm going to go ahead and put 7 millimeters right here. And that would be my height. So now I have all my dimensions for my first shape. Volume equals our length times our width times our height. Volume equals my length, I'm going to plug in my 19. My width, I'm going to plug in my 5. And my height, I'm going to plug in. So then volume, I know 19 times 5. I know 20 times 5 is 100. So one less group of 5 gives me 95 times 7. And then if I go over here and just do some quick little side work, I know that that's 35. So then that would be 63. So plus 3, 66. So I get my volume equals 665 millimeters cubed. Bigger numbers, but definitely wasn't too hard for me to solve. I didn't need to use a calculator for that one. This one right here, number 2. So that's my shorter one, the kind of like that one they added to the top of my shape. So volume, again, I'm going to use my length times my width times my height. And in this case, I need to figure out this dimension right here. So again, they didn't give it to me because it's an added part. I don't see it up here. I don't see it here for me to kind of bring down. So I got to use what's around me to solve it. So what I do know, again, is that this entire length is 19 from here to here. The other thing that's going to help me in this one is the fact that this over here is 11. So this right here being 11 and the total being 19, if I just kind of chop that off and say I know from here to here is 11, that means this part from here to here has to be 8. So that's going to help me right there, that I know I have length is 8. I need this dimension right here, which is the same as this one. Not labeled, but it's the same as this one. So I know if this is 5, then this up here has to be 5, and then I can clearly see my height is 10. So volume is 8 by 5 by 10. I'm going to go ahead and just do 8 times 5. I know that's 40, so I have 40 multiplied by 10. So 40 times 10, I ended up with 400 millimeters cubed. Last step, find my total volume. To get my total volume, I'm just going to combine my two shapes. So I'm going to do 665 plus 400 more, and that would give us an answer of 1,065 millimeters cubed. So I didn't need to use a calculator for that one because the numbers weren't too bad. So hopefully most of the examples I'm going to give you today you could practice without. But if you need to use a calculator, that's fine, guys. When I look at the other way, I could have split this problem. Just to kind of walk you through the difference. The other way I could have done it, I did this over here, is to cut it the long way. So I went this way right here, and that split that into this long shape, number 1, and then this shape, number 2. So I did the same kind of thing as that work up here, but what I saw was that I had a length of 8 by 5 by 17 for that long shape. And then on that little shape right here, I had a length of 11, right there, by 5 with our height being 7. I had to figure out the height for that one there using, again, what I knew over here. This right here, I solved my shape number 1. Volume is length times width times height at 8 by 5 by 17. I multiplied 40 times 17 to get 680. You can see all my work there as I solved. Other way would have been shape number 2, 11 times 5 times 7, multiplied 55 by 7 and got 385 millimeters cubed. Last step, I added up the volume, and even though I split my shape a little bit differently that time, and I had 680 plus 385, I added those up, and I still got the exact same answer. So 1,065 millimeters cubed. So it doesn't really matter which way you guys think about splitting them up. I'm going to model for you throughout maybe a different way that you didn't approach it, but even if I approach it different than you, we should both get the same answers. So keep that in mind and just practice splitting your shape into more than one and practice those next examples. If you want, you can print the PDF version so you have your own copy, or you can draw them on another piece of paper. All right, guys, good luck. Give it your best shot and see what you can come up with.